Hi everyone, welcome to Focal Academy. So in this problem, here this is a problem we are going to solve by using Superposition Theorem. So one circuit given here. So for the circuit, two voltage sources are there. So one is DC voltage, one is AC voltage. And asking that how to find current I0 that is passing through inductor. How can you find it? So according to Superposition Theorem, we know that each source has some contribution in the current. That means, so due to this source, there is some contribution, the current in inductor. So this source also having some contribution, the current in inductor. So let due to DC source, there is some contribution, that is current I1, and due to AC source, there is current, that is I2 is contributed. So here this I1 entering here, I2 is entering here in this direction. So according to KCL, incoming currents equal to outgoing currents, that is I0 equal to I1 plus I2. So here I0 is the current passing through inductor, so that is equal to the current contributed by DC source plus the current contributed by AC source. Now how to find current I1 and I2? So according to Superposition Theorem, so whenever if you want to find the contribution of current by any source, at that time short circuit the voltage sources of other sources, and if there is a current is there, open circuit it. So here I am going to find the contribution of current for this DC source. Now there are only one other source is there, that is voltage source. So voltage source are short circuited. So make it short circuit here. Now keep elements as is. So 4 ohms and here 2 ohms, and DC voltage is plus minus, that is 8 volts. So here this is a DC voltage. So according to the properties of inductor, for DC voltage it should be short circuited, means it acts as a short circuit. So in the place of inductor now draw short circuit. Why means here the voltage is DC voltage. So for DC voltage, inductor is a short circuit. Now the current in this branch, that is equal to, according to Ohm's law, voltage by resistance, that's equal to 4. 4 amperes is the current, that is I1, which was contributed by DC source to the inductor. Next we want to find current I2. So this current was contributed by this voltage source. So at that time, read our circuit. So this is voltage source was given with voltage 10 cos 4t, and a resistor, and here one inductor, and here one resistor. Now I am going to find the current contributed by this voltage source. So according to Superposition Theorem, so while finding current contribution, at the time short circuit the other voltage source and open circuit the other current source. So here other only one voltage source is there. Now short circuit it. This is 4 ohms and here this is 2 ohms. So convert this into frequency domain for easy simplification. So this here amplitude is 10 and phase angle is here 0. So 10 with phase angle 0. Now here resistance is nothing but impedance only. For inductor here 1 Henry is given. So for inductor SL is the impedance. So S means J omega into L. L is given as 1 Henry. So 1, and omega is nothing but cos omega t. So omega is 4. So J4 into 1, nothing but 4J. Now how can you find current I2 in the inductor? So this is current I2 due to this voltage source. So I am going to use source transformation technique for simplifying this. So here voltage is there and resistance is there. So whenever voltage a resistor in series, it can be replaced with a current source with parallel resistance. Suppose here R is there, here V is there. Now current becomes here V by R and R is R only. So in the place of this piece, I am going to replace this circuit. Means in the place of this, I am going to use this part. Means this is called as source transformation technique for simplification. So it becomes here the current is V by R. Here V is, this is 10 with phase angle 0 and R is 4 ohms, that is 10 by 4 with phase angle 0, that is 2.5 with phase angle 0. Now draw one resistor which was parallel, that is only 4 ohms. Now keep remaining as it is, there is no change. So here one inductor which was parallel with 2 ohms. These two components are in parallel. Careful observe here. This is inductor that was parallel with 2 ohm resistance. So inductor is 4J and resistance is 2 ohms. Now here 4 ohms and 2 ohms are there which are in parallel, both are resistors. Now replace with single resistor because both are in parallel. Now I am going to replace with single resistor. So after real circuit, so here this is current, that is 2.5 with phase angle 0. Whenever two resistors are in parallel, so here 1 by 4 plus 1 by 2 equal to 1 by R, that is overall resistance. So R becomes here LCM is 4, so 1 plus 2, nothing but 3 by 4 equal to 1 by R, so R equal to 4 by 3. So this is the overall resistance for these two components. Now replace with single resistor, that is 4 by 3. Next inductor. Inductor is 4J. So in the inductor we have current, that is I2. Now we can easily find current I2 by applying current division. Let's see here how to apply the current division rule here for finding current I2. So in this inductor I want current. So at that time take the other branch, means among other branch impedance, that is 4 by 3 by overall impedance, that is 4 by 3 plus the impedance of inductor, that is 4J, into source current, this is 2.5 with phase angle 0. By simplifying this we will get 0.79 with phase angle minus 71.56. So this is current I2. So I1 we got 4 amperes and I2 we got this is, that is 0.79 with phase angle minus 7.56. But we want I0. I0 is I1 plus I2. Now add these two, we will get I0 value. So that be equal to I0 equal to 4 plus this value, that is 0.79 with phase angle minus 1.56. It can be written as, that is I0 equal to, keep this is DC, that is 4 plus. So it can be written as in cosine form. This is amplitude, that is 0.79 cos omega t. Omega is 4t plus phase angle is minus 71.56. So this is the current I0 for the given problem, and this is the process of simplification by using superposition theorem. Thanks for watching. Please subscribe, like, share. Thanks.